Hey guys, Screencast 7.5 practice. So this is just going to go over the practice page that you should have completed in class, and if you didn't get it done, completing for homework. So starting out, we are going to add, subtract, or multiply. So this is number 1, letter A. You just have negative 5 plus 6i minus 1 minus I. So because we have this negative here, this minus here, we change that to a plus, and then everything that comes after it in the parentheses, we change the sign. So we make that 1 negative and that I positive. Now I can drop the parentheses, so I have negative 5 plus 6i minus 1 plus I. And now I can combine the like terms. So negative 5 and negative 1 make negative 6. And 6i and 1i make 7i. So we should have negative 6 plus 7i. Number 2, we have negative 2.4 minus 5.6i plus 5.9 plus 1.8i. So here I have addition, so I don't have to worry about doing anything with that sign. So I just simply drop the parentheses, negative 2.4, minus 5.6i plus 5.9 plus 1.8i. Look for your like terms. Negative 2.4 and 5.9 makes 3.5, and negative 5.6i and 1.8i makes negative 3.8i. And there's our solution for number 2, or B. Okay, so on to the next. 1C, we have negative 4i times negative 6 plus I. So here we just have the distributive property, so negative 4i times negative 6 is positive 24i, and negative 4i times I is negative 4i squared. Now remember, the I squared is special in that it turns into a negative 1. So instead of negative 4 times I squared, I have negative 4 times negative 1 with the 24i out front. So simplify 24i, and then negative 4 and negative times negative 1 make a positive 4. And then if we want to write it in the correct form, we should have the imaginary number in the back, so we have 4 plus 24i. Okay, and then 1D, we have 2.5 plus 1.5i times 3.4 minus 0.6i. So we go through and we do our FOIL. So 2.5 times 3.4 is 8.5. 2.5 times negative 0.6i is negative 1.5i. 1.5i times 3.4 is 5.1i. And 1.5i times negative 6i is negative 0.9i squared. So again, go through, simplify. So at 8.5, I don't have anything to combine with right now. These guys here, negative 1.5i and 5.1i, can combine to make positive 3.6i. And then the minus 0.9i squared, remember the I squared automatically becomes a negative 1. So this is negative 0.9 times negative 1. So back to simplifying, or simplifying continued rather. So the negative 0.9 times negative 1 is a positive 0.9. So now that is going to be able to be combined with the 8.5. So 8.5 plus 0.9 is 9.4 plus 3.6i. And there's our solution for 1D. On to number 2. Number 2, there's really no math involved. You just need to know the vocabulary. So conjugate. So conjugates are a plus bi and a minus bi. So the real part stays the same. That would be your a. That's the real. The imaginary part switches signs. So if it started out positive, it's now going to be negative. If it started out negative, it's now going to be positive. Okay? So these guys here, for A, you have 5 minus 4i. For B, you have 7i. And for C, you have negative 3.25 plus 4.82i. So for your solutions, this would just be 5 plus 4i. This would be, the imaginary part is only here, not the real, so I have to change the imaginary to negative. So negative 7i. And C, the real part stays, whoops, 3.25, and the imaginary part switches, so from positive to negative, 4.82i. And those are your solutions for number 2, A, B, and C. Okay? Now, we use conjugates for number 3 in order to rewrite each quotient in the form of A plus BI. So here we're dividing. So we have, for A, we have 1 plus I, oops, it's not in parentheses. I put those in later. 1 plus I over 1 minus I. So remember, here we're going to multiply by the conjugate of the denominator. So this is conjugate, which is what we just learned in number 2, or what you've already known, but we practiced in number 2. Conjugate of denominator. And that's what goes in the numerator and denominator of this fraction that we multiply by. So the conjugate, again, the real part stays. The imaginary part changes sign. So instead of 1 minus I, we end up with 1 plus I, and that also goes in the numerator. So now we take these two and we multiply straight across. So I'm going to do the numerators multiplied and the denominators multiplied. So that equals, nice long fraction. We FOIL, or you can use your area model if you want to. So we have 1 times 1 is 1. 1 times I is 1i, I times 1 is 1i, and I times I is I squared. Denominator, 1 times 1 is 1, 1 times I is 1i, negative I times 1 is negative 1i, and negative I times negative I is negative I squared. So I'm just going to erase this note here so I can continue the problem. So moving on, this equals, we simplify our numerator, so I have 1, and then 1i and 1i make 2i, and I squared is a negative 1, divided by denominator 1, 1i minus 1i, those guys cancel, and I have negative I squared, which turns into a positive 1, because this becomes negative times negative 1, which is your positive 1. Simplify further. The 1 minus 1 up here, they cancel, so I'm left with just 2i, and 1 plus 1 is 2. And finally, doing my division, 2 divided by 2 is 1, so I have 1i, which is the same as just saying I. So either one of those answers would be acceptable for A. Okay, moving on to B. Whoa, that got tiny. I don't know how I did that. Okay, B says, nope, no parentheses, 3 plus 5i divided by 6i. So even though the bottom is not a complex number, it's just imaginary, I'm still going to multiply by the conjugate. Remember, the conjugate is the opposite of the imaginary. So this imaginary is positive, so the opposite is negative. So multiply by negative 6i, top and bottom. So I'm going to put these in parentheses, and now I multiply. 3 times negative 6i is negative 18i, and 5i times negative 6i is negative 30i squared, divided by 6i times 6i is negative 36i squared. So continuing here, negative 18i minus 30 times I squared is negative 30 times negative 1. So that'll simplify to negative 18i plus 30. Negative 36 times negative 1 is a positive 36. So now I just have to do the division. So you divide negative 18 by 36, and that's negative 0.5. That gets the I. And then we divide positive 30 by 36, and we get 0.83. It's repeating, but you can just round it to 0.83. And there's our solution for 3B. Okay, so those were all from the investigation. Now we come up to problems that come from the first screencast that I did for 7.5, and that's solving the equation. Remember, every equation can be solved using the quadratic formula. Especially if it can't be factored, then you must use the quadratic formula. So looking at A, you have x squared minus 2x plus 5 equals 0. So it's quadratic with the x squared, it's equal to 0. So if I try factoring, I need two numbers that are going to multiply to 5 and add to negative 2. So think about it. Two numbers that multiply to 5 and add to negative 2. What are they? There is no such thing, because the only numbers that multiply to 5 are 1 times 5, and when we add 1 and 5, we get 6, or negative 1 and negative 5, but when we add negative 1 and negative 5, we get negative 6, which means this cannot be factored. So we have to use the quadratic formula. Remember, quadratic formula, opposite of b, plus or minus square root b squared minus 4ac divided by 2a. Got it memorized yet? All right, so a is always with x squared, so that's a 1. B is always with x, so that's negative 2. And c is always the constant, so that's 5. And we plug in. So I have negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 divided by 2 times 1. Continuing to simplify, this equals positive 2 plus or minus the square root of 4 minus 20 divided by 2, which equals 2 plus or minus the square root of negative 16 divided by 2. And here's where, up until a couple of days ago, we would have had an issue. But remember, this negative now can be actually solved. So the square root of negative 16, we automatically break it into the square root of negative 1 because we have a number for that now, and that number is I. So what times the square root of negative 1 will give me the square root of negative 16? Well, negative 1 times 16 will give me negative 16. And do we know the square root of 16? Yes, we do. It's a perfect square, so it's a 4. So the square root of negative 16 is equal to I times 4, which is 4i. So I'm going to now replace the negative square root of 16 with 4i. I'm going to put that in there. Okay, this is going to look like this. 2 plus or minus 4i divided by 2. And now we do our division. So we do 2 divided by 2, which is 1, plus or minus 4 divided by 2, which is 2, and that one keeps the I. And here are my solutions. I have two solutions, one plus 2i and one minus 2i. This is a complex solution. Okay, complex solution, just so you know, because there is a real part and an imaginary part. That's what makes it complex, because you have one of each. The real part is your 1, the imaginary part is your 2i because it has the I. So that's what we call a complex solution. On to B. B can be solved simply by taking square roots because there's only one x here, or you can use quadratic equation. Quadratic equation is a little bit longer, but either way, you come up with the correct solution. So if you're going to use the quadratic formula, you end up with a should be 1, B is 0 because the x term is missing, and C is 7. And then you should plug it into the quadratic formula. Okay? Okay. So otherwise, you can use square roots like I showed in the other screencast because there's only one x. Whereas in A, what do I mean? In A, we had x squared and a 2x. So there were two different x's and we couldn't combine them because they're not like terms. But in B, there's only one x here. So I can actually just solve this by undoing my order of operations. So I would subtract 7 from both sides, and x squared would equal negative 7. And then how do we undo squaring something? Well, we take the square root. So I do the square root of x squared and the square root of negative 7. So that would give me x equals plus or minus the square root of negative 7. And again, here we run into the idea that we have a square root of a negative. So again, little sidebar, square root of negative 7, automatically into square root of negative 1 times, and again, we have 7. So the square root of negative 1 is automatically an I times the square root of 7. Now, 7 is not a perfect square, so I don't want to actually take the square root. I don't want a decimal. And since there's no other perfect square factors inside of 7, I'm simply leaving it as the square root of 7. So the square root of negative 7 equals I times the square root of positive 7. So our final answer is x equals plus or minus I times square root of 7. And that's how you would write that answer. This answer is just imaginary. It's not complex because there's no real part. So because there's only the imaginary part of this solution, it's not a complex solution, it's just imaginary. Okay, on to C. So C says x times x minus 5 equals 0. So if you notice, this equation is already in factored form. And if you pick up on that, then this makes this problem a whole lot easier. Because when you're in factored form, you can apply the zero product property, or the ZPP, which tells you that either one of these guys would have to equal 0. So x equals 0 is an answer, or here you would solve it and find out that x equals 5. Well, these are normal looking answers. They're plain old numbers. There's nothing imaginary about them, so these are real solutions. Okay? If you did not pick up on that, then maybe you started out by distributing and you got x squared minus 5x equals 0 and decided to use quadratic formula. And that's fine too. You should still get the same solutions. So here you would have A is 1, B is negative 5, and now C is missing because your constant is missing. And then you could take this and put it in to the quadratic formula. Again, you should still get x equals 0 and x equals 5. It's just a little bit of a longer way of solving it, but it's absolutely fine to do that. Okay, so I hope that you've studied a little bit and you've looked them over. Hopefully you've tried them all on your own first before watching this. You will have a quiz next class, so I will see you then.